Class B, the first 2 bytes are net ID. The remaining byte 3 and 4 are host ID. Consider the class C address. The first 3 bytes are net ID. The last byte is host ID. So this is a classful address representation. In a binary form, the classful address is leading the value binary digit is 0. In class B, it is 10. In class C, it is 110. Class D, 1110. It is starting with 1110. In class E, 41. So based on this leading binary value, we can identify which class the IP address is. Most probably, the class D address is used for multicast purpose, and class E is used for future reservation purpose. So we can find the class of IP address in two ways. In binary notation, based on this representation, we can classify them. So if the leading value is 0, it is class A. If the leading value is 10, the given address is class B. If the leading value is 110, it is class C. So like that, it goes on. If in dotted decimal notation, according to the range of the value, we can classify them into either class A, B, or C. So if the range is 0 to 127, it is class A. 128 to 191, it is class B. 192 to 223, it is class C. Likewise, 242 to 255 means that is a class C address. So this diagram represents how the address spaces are occupied by different class of address. So the class A occupied 50% of address space. Class B occupied 25% of the overall address space. Class C occupied 2 power 29, it is 12.5% of the overall space, where class D 6.25. Class C, D and E occupied 6.25. So this table clearly explain about different types of classes and the leading bits in the binary notation, the net ID representation, host ID representation, number of networks, and the address per the network, starting address of each class and the ending address of each class. These are the sum of the problem to convert the given IPv4 address from binary notation to dotted decimal notation. Whatever the problem I discussed previously, we can apply the same rule here also. This is another one problem to find the class of each address for the given binary notation and dotted decimal notation. So instead of doing one byte by byte, simply we can identify this binary is starting with the leading 0. So it is a class A address. It is starting with the value 110. Okay, so it is the first 2 bits are 11. So the third bit also 0. So it is a class C address. In the dotted decimal notation, the first byte is 14, which is in the range class A, whereas 252 is in the range of class E. So based on the leading bit value and the decimal value, we can easily identify which class it is having. In the communication, we can do the data transmission in unicast and multicast purpose. The class A, B, and C are used for unicast data transmission, whereas the class D is used for multicast data transmission, and class E is used for future reserved purpose. In the classful addressing, the large part of the available addresses are wasted. So to overcome that, the subnetting concept is coming. Each and every class is having a different subnet mask. Coming to the class A address, the subnet mask, the default subnet mask for class A address is 255.0.0.0. It is a /8 CIDR value. Whereas a class B, the first 8 bits are having 1. So 255.255.0.0. The CIDR value for class B address is /16. Similarly, class C address, the first 3 bytes are having the value 1. So that is used for a net ID. The last 1 byte is used for host ID. So the corresponding default mask for that class C address is 255.255.255.0. The CADR value for this is /24. In classful addressing, it is obsolete and it is replaced the extra memory space are effectively utilized by the classless addressing. So this is a symbolic representation of IPv4 addressing x dot y dot z dot t. Each variables are having 8-bit data, so totally 32-bit size /n. N defines the mask value. In order to identify the first address in the block, we can shift the rightmost 32 minus n bits to 0. So for that, one problem also given, the block address is granted to a small organization. The one of the addresses is given 205.16.37.39/28. Now, the problem is to find out the first address in the block. So convert the given address into corresponding binary form. Then it is of /28 CADR value. So if we say 32 minus 28, which is nothing but 4. So the 4 bits, rightmost bit to 0. So it has the value, this one. So 111 If we change this 4 bits into 0, we will get the first address. So convert this 4-bit 0 and 111 changed into 40. We will get the corresponding decimal notation 205.16.37.32. So this is the first address for the given IP address, 205.16.37.39. Similarly, to find out the last address in the block, that can be found by setting the rightmost 32 minus n bit to 1. So consider the same IP address. Okay, 32 minus 28, 4 bits. So that rightmost 4 bits are changed into 1. So now this rightmost 4 bits are changed into 1. We will get the corresponding decimal notation .47. So 205.16.37.47 is the last address for this network. Similarly, we can also find the number of address in the block. Okay, using the formula 2 power 32 minus n for the given IP address. So 2 power 32 minus 28, which is nothing but 2 power 4, which is equal to 16. So this is in this way we can calculate the number of address for the given IP address.